Hi guys, it's Jerry here, and today I'm going to teach you about chromatography. Now, what even is chromatography? Well, chromatography is pretty much the separation of colors that make up another color. Like, if you had a marker and you placed a dot on a paper, that dot is actually made up of many different colors combining into that specific shade of color. But when you place a dot on a piece of paper, all you see is one color. So how do scientists figure out what colors make up that dot? In this video, I'll be answering that question and showing how you too can separate colors at your own home. So how does chromatography work? Basically, to separate colors from the dot, all you need is just paper and water. The paper allows the water to diffuse along the surface while picking up certain colors farther than others, separating them back into their original colors. The colors that make up the dot are actually molecules in bulk. So based on the molecule, it could be picked up by the water more or less. This separates the ink into its original colors. In scientific terms, the water is called the mobile phase, while the ink from the marker is called the stationary phase, as it doesn't move without the diffusion of the water. The amount that the molecule gets picked up by the water depends on the molecule's intermolecular force, aka IMFs. IMFs are the forces that hold molecules together as a solid, liquid, or gas. Due to IMFs, some substances are more likely to stick together, but others don't stick together at all. An example of this would be oil and water. In this case, the amount of water that sticks to one color depends on the polarity of that molecule. The more similar the molecules' polarities are, the more likely it is that they will stick to each other. So if we conducted this experiment twice, one time with a polar molecule like water, and another time with a slightly less polar molecule like acetone, we actually could find the polarity of all the colors and rank them by that. We could do this by comparing how much each color moved up with each substance. To do this experiment, you'll need 2 beakers, one for water and the other for acetone, 4 strips of filter paper. You could use any paper, but filter paper works best, and a ruler to measure how much the colors traveled up the paper. For this experiment, I used both washable markers and Sharpies to see the difference in their polarities. To measure the amount the color traveled up the paper, people use RF, or retention factor. The equation for retention factor is how much the color traveled up the paper divided by the distance the liquid traveled. This is so that the value will always be between 0 and 1. The setup should look like this. You can see the papers each with a dot on them. To start the experiment, all you have to do is to place them into the liquids. But don't submerge the dot into the liquid or else the experiment won't work. If you do the experiment correctly, it should look like this. As you could see, you could easily get a rough position for each color. In this case, the colors that make up this vibrant purple are magenta and violet. I conducted this experiment at my school, and I made a table chart and graph of all the RFs for all the colors that make up each marker. Using the table and graph, I was able to rank all the colors by their polarity. I did this by comparing the RF values for each color in each solution. Here's an example. When comparing the colors purple and pink by polarity, you could see that the pink traveled farther in the less polar liquid than it did in the water, while the purple traveled farther in the water than the less polar liquid, or acetone. This means that the purple is more polar than the pink. As the more similar the molecule and the liquid's polarities are, the farther that the molecule travels up the paper. I conducted this experiment twice, one time with a Sharpie and another time with a washable marker. When comparing the markers, you'll notice that the washable markers are way more polar than the Sharpies. This is by design, so that they easily stick to the water when washed. This is further reinstated by the fact that my fellow classmates conducted this same experiment and got really similar results. Now that you've completed your experiment, give yourself a pat on the back. But that's not the only way scientists do chromatography. There's a whole world of different kinds of experiments that separate the colors from another color. I hope that after this video, you feel enlightened by the power of chromatography.